In this video, I will demonstrate how flexible demand can be used as a preemptive measure against power system instability. This is another creative approach that we pursue in the SOSPO project to improve the stability of future power systems. In the SOSPO project, we aim to find ways to use real-time information of the system variables to assess the stability and security of the system in real time. When insecure operation is detected, we use fast methods and algorithms to determine a suitable control action to re-establish security. In this presentation, I will demonstrate the use of flexible demand as such a control action. Let us begin with this simple network. A generator supplies power to a system and has a stability margin based on internal generator impedance and network impedance. But a certain line outage can bring the generator too close to its stability boundary and become unstable. This makes the system vulnerable to the line outage and thus insecure. Now, if we change the loading in the system by using flexible loads, some loads could start to consume less power and others could consume more. We can then make a change to the system that affects the line loadings and impedances. The system is now more resistant to the line outage and more stable. This is the objective of this presented part of the SOSPO project, which we call wide area prosumption control. Let us now take a look at how we can do this. Flexible demand can only be altered for short periods of times without affecting the services provided by the loads. Devices such as refrigerators, ventilation systems, and electric cars have an indirect storage of energy which can be used, for instance by delaying charging an electric car. To simplify the flexible loads, which can be hundreds of small units, the resources are estimated and modeled as a virtual battery with a power and energy capacity. We then use methods which can estimate the available resources based on the types of loads found in different areas. I will now show how the algorithms identifies the required change to flexible demand which can increase the security of a system. The following network shows a generator which will violate its stability margins if a given line fault occurs. After the threat has been identified, the nearby resources are modeled and loads are aggregated and shown as virtual batteries. Based on the electrical distance, the nearest resource is selected. Using efficient estimates of the effect of changing the loading, the result of the change is evaluated. Distant resources are then utilized to counter the change in system loading to maintain the frequency balance. If more resources must be utilized for the generator to meet its margin, these are selected and evaluated as well. If the changes are sufficient, a signal is sent to the loads to alter their consumption. The system can now withstand the line outage if it should occur. This makes it possible for the system to adapt to an unforeseen threat and take actions to reduce its impact before the threat happens. This can be used to buy time during critical operating conditions, for instance right after a major fault in the system. Flexible demand can respond instantaneously to a control signal and could provide a powerful and cost-effective control resource. This, along with the other innovations in the SOSPO project, can allow the system to be operated with smaller margins and utilized more efficiently. This is one way in which the SOSPO project utilizes new approaches to improve the stability of the future power system. For more information, you can visit our website or join us for a technology presentation. Thank you for listening.